Okay, we're about to start proof number 2 here. And actually, the proofs that I'm doing, I pulled from the book. We're going to do one more, the ones in the example problem. So we're actually in section, it's 9.4. Yeah, sorry, we're in section 9.4. If you want to go and look at some of those example problems or read through section 9.4 for a little extra help, that's where it's at. In 9.4, they talk about segments and angles, and I want to try to cut it down for you. So we're just talking about segments today, practicing with segments, and then we'll tackle angles next time. But before we get too far into this proof, we need to come back to a piece of information that we had from a way, way, way back. This is actually from section 8.2. Way a long time ago, we defined this, and we talked about this. It's the segment addition postulate. And it's, it seems kind of obvious, but that's why it's a postulate, right? Postulates are things that are proven or that are taken to be true without proof. So this is kind of the idea. If B is between A and C, then the measurement of AC is the measurement AB plus the measurement BC. So if B is between A and C, now the word between, we actually defined as well, a long time ago. Between means specifically that it's collinear with these two, and it's on the same line as them. So between is on the same line and in between them. If B is between A and C, then we know that AB plus BC is equal to AC. Right? This guy plus this guy is equal to the whole thing. So this right here, this is the measurement of the segment AB. This is the measurement of the segment BC. And then this whole thing right here is the measurement of the segment AC. So this little guy, the measurement, plus this little measurement is the whole measurement. Which, again, is okay, yeah, that makes sense. But yeah, that's why it's a postulate. Okay, so that's the segment addition postulate. It allows us to take segments on the same line, or the segments that are collinear, and basically add their measurements together to get the measurement of a bigger one, which is going to be important in this next proof. Okay, so over here on the far side of the board, I've just kind of listed out some important definitions or postulates that we're going to need. These are the 3 most important for this assignment today. Definition of congruence is going to come up a whole lot, and remember that's how we switch gears from congruence properties to equality properties. If we can get to equality, that's great, because now we have 5 other properties we didn't have before. Definition of midpoint is going to be helpful, especially in this one, because if it's in the given, we're going to need to know what that means. And then the segment addition postulate is going to allow us to put chunks of these guys together, put the 2 segments together. So those are what we're going to have to use in this proof, and these are actually going to be the big 3 that we're going to use today. So segment addition postulate, we're just going to kind of tuck it away over there. We're going to get rid of it. I just wanted to show you what that looks like first before we tackle this proof, just to review. Okay, so now let's actually get into the proof and see what's going to happen here. Given M is the midpoint of AB, okay, prove AB is equal to 2AM. So we want to prove that this length is twice the length of this guy. Okay. Now, when we talk about midpoint, that should automatically have you thinking congruence, right? Midpoint means it cuts it into congruent segments. That's the definition of midpoint. So let's draw our table for our 2-column proof. And over here we're going to have statements. And then our justifications are going to go over here. Okay, justifications have to be some kind of established postulate or theorem or definition or property or construction, which we won't use very often, but we will from time to time. So that's what can go over here. Anything we already have established is true. So let's start off with M is midpoint of AB. Okay, how do we know that? Given, right? That's how we start. Okay, now we want to prove this guy. So our last statement should be AB equals 2AM. Okay, we don't know how we're going to get there yet, but we need to fill in the middle part here. Okay, how we know where to go is what does this tell us? This has to tell us the next piece, and then we build from that piece on, and so on and so on. That's deductive reasoning. So midpoint tells us, again, that we have two congruent segments. That's what the definition of midpoint. Midpoint cuts a segment into two congruent segments. So what I can say then is that AM is congruent to MB. Okay, and the reason we can do that is the definition of midpoint. Okay, cool. Well, what does that tell us? What does it mean for two things to be congruent again? It means their measurements are equal. So that means we can say that AM is equal to MB. And again, how we move from congruence land into equality land is the definition of congruence, or def of cong, as I like to call it. And now we have more properties that we can use. Now we can actually like add things to both sides if we wanted to, or divide by both sides or something like that, or substitute. Okay. All right. Now the next statement comes in with the segment addition postulate. So because of the way we have this set up right now, we can already make some claims about AM and MB and AB because of the segment addition postulate. So the idea is the measurement here plus the measurement here equals the full length. This guy right here, the measurement of this segment is AM. That's how we refer to this length. This length right here is MB, and then this length right here is AB. Okay, so what we know is that AM plus MB is equal to AB. And how can we say that? What's the justification? We need to build on something that we already know, and it's the segment addition postulate. Right, that's something we knew was true from a couple weeks ago. So that's a fact that we know, right? We're building our case here. Okay, now this looks a lot like an equation, doesn't it? And we're trying to get to the point where we have two AMs equal to AB. So this is kind of weird, but let's look at these two equations together and see what we can do, see what kind of properties of equality we can use. Well, I know that AM and MB are equal to each other. So if I know two things are equal, that means I can use a substitution property. We don't have a substitution property of congruence, but we do have a substitution property of equality, which means I can replace this guy with something that it's equal to. So in this statement, I'm just going to rewrite this statement right underneath it, but I'm going to just change one little thing. So AM is AM. That's still the same thing, right? And AB is still AB. But this guy, I can replace this with something else. I can replace it with that guy, because they're equal to each other, right? Property of equality. So I can say AM plus AM. Right? How did I do that? Well, they're equal to each other, so that this guy can get replaced with that guy. So that's happening right here. Okay? So I'm kind of diagramming it out for you a little bit, but you wouldn't normally do that in a proof. Okay, so what do we do here? This was the substitution property of equality. It's a good thing that we're in equality land, because there's not a substitution property for congruence. So that's cool. Can you see where we're headed now? Can you see where we're almost there? What is AM plus AM? Well, if I have two things that are similar, like x plus x, that's 2x, right? If I have y plus y, that's 2y. If I have 3 plus 3, that's 6. That's the same thing as saying 2 times 3. Right? So if I have two of the same thing and I'm adding them together, what I'm going to get is I'm going to get two of them. So I can say that this is 2 times AM. Now remember, AM is just a measurement. It's just some number. We don't know what it is, but it could be like 5 or 10. It's some measurement here. So this is just 2 times whatever that measurement is. And that's going to be equal to AB. And again, that's the substitution property of equality. You may be thinking, well, hey, isn't that the addition property of equality because you're adding? Addition property of equality is when I add on both sides and keep it balanced, right? So even though I'm adding these together, that's not the addition property of equality. That's just replacing this with what it's equal to. What's AM plus AM? Oh, AM plus AM is equal to 2AM. Great, okay, replace it with that. All right, so that's substitution property of equality. Now we're almost there. Like we pretty much have the statement we're trying to get, but it's backwards, right? It's reversed. So how do we get it back to the order that we want it in? Because these statements are equivalent, but we haven't said exactly what we want to say yet. We just need to change it. What's the property that says this is equivalent to this? It's the symmetric property of equality. Okay, we said what we set out to say. So we're done here. We justified every single step. Every single justification is either a property or a definition or a postulate, something that we already know is true. We've already established these are true. There's a little bit of kind of algebra stuff going on here, a little bit of weirdness with the segments. This is what algebra looks like with segment measurements. It's a little bit weird, but that's why we start with regular algebra, with like x's and stuff, so that this isn't quite so crazy. So there's still some algebra steps going on here, but we're starting in like geometry land, and we're kind of fusing these two worlds together. Okay, so that's proof number 2. There's going to be one like this on your homework, so look out for it. And you can use this as a template to kind of follow the steps and just kind of make sure you understand what's happening here.